joining us today as we share with you our school's journey in transitioning to Python as the primary programming language in our digital technologies faculty. My name's Carolyn and this is Pravin, and we're both teachers, digital technologies teachers from Mazenod College. Today we're going to outline the key reasons behind this decision, the steps we've taken to pilot the new language in key subjects, and the challenges and opportunities we've encountered along the way. We'll be sharing what this transition has meant for our faculty, our students, and the learning and assessment processes which underpin the way we teach. Mazenod College is a Catholic all-boys school located in Mulgrave in Melbourne's southeast with roughly 1,400 enrolments. Inspired by the charism of St Eugene de Mazenod, Mazenod College has a strong reputation as a welcoming and inclusive school with excellent academic results. Mazenod College resides in the top 10% of Victorian schools, which is highlighted by these key statistics of results achieved by the graduating class of 2023. VCE software development as a subject at Mazenod has long attracted high-performing students, with an enhancement pathway offered where students have the opportunity to study Units 3 and 4 in Year 11 after completing an extension subject in Year 10. High-performing students actively seek the opportunity to join the program. The excellent results achieved by students in the subject have been constant year on year. The median study score has been above 35 for the last 5 years, and during that time, 2 students have received a perfect 50 and each a Premier's Award. Last year's cohort, as you can see on the slide, achieved a 36 median study score, and 41% of the cohort achieved a study score of 40 and above. One of the key factors influencing the success of this subject at Mazenod was the rigorous curriculum that was purposefully structured from Year 7 all the way through to Year 12. You can see the entire curriculum pathway on the left. It's not very clear on the slide. However, the Year 10 focused subjects are highlighted on the other side. All students complete a mandatory semester-based subject of digital technologies in Year 7, and in Year 9 they have the option of studying a semester-based elective on an ICT pathway. So in Year 7 and 9, coding is visual block coding. We're utilising applications such as MakeCode, Scratch, Lego Mindstorms and Drone Blocks, and text-based programming is introduced at Year 10. So historically, Visual Basic was the language of choice, and the key reason for using Visual Basic was really the ease of using Visual Studio as the IDE and the well-supported graphical user interface component. The visual approach of the form-based applications made it engaging for students learning to code, but also made the teaching of object-oriented programming inherent through the use of forms, objects, and classes. The teacher who developed the curriculum had the approach that coding is skills-based and therefore really easy to learn. So rather than focusing on explicitly teaching computer science-based theories and concepts to students, they used a series of programming tasks and activities which enabled students to learn coding concepts through practical application. The intention of this was to build confidence and self-efficacy in coding and challenging the myth that programming is really difficult. At the end of 2023, the long-serving Unit 3 and 4 software development teacher retired, creating an opportunity for a new way of doing things.
So Visual Basic has been adopted in the classroom as a programming language since the 90s. I recall seeing an instance of Visual Basic on my teacher's computer back in high school in India. There were about 25 computers. One screen was color, the rest, 24 of them, were monochrome. And the teacher's computer, of course, had VB, whereas the other computers, we did DOS commands and played Aladdin when we could. But when we got the opportunity to actually use the teacher's computer, we were allowed to use VB, and the teacher's book had the instructions, say, drag and drop this, and type that in, without being really told what you're actually doing. We were just doing as we were told. That was an interesting time. Moving on, VB rebranded as VB.net, and Microsoft became the mainstay of all software in classrooms or coding in classrooms. However, to fully and proficiently utilize the language, there were a number of skills required to be developed by the introductory student. Knowing which package to be installed and learned in the MSDN would be a challenge for most developers, let alone course coordinators like myself, to try and come together with a course for a high school student or a university student. So while VB became the dominant choice for business applications, it was a no-brainer to adopt Microsoft Visual Studio in the classroom to prep the next generation of students for the workforce. So here we are with Visual Studio in our school, and when the students load it up, this is what they're greeted with. So it says, build an app, your first app, in 5 minutes or less, and throws up ASP.NET Core MVC, whatever that is. Tells you, click on that, follow the instructions, and you'll build a web app in 5 minutes. But it's not, in our opinion, it's not really relevant for high school students as their first program, at least. We also had a number of issues with compiling code. For example, it compiles as a .exe, and our IT has blocked running any executables, of course. So students copy the entire solution folder and copy it over onto a backend system, which is called Harpera, which is from New Zealand, because that integrates with Google Drive as the backend, and that then sits into the LMS. So we open that folder to access all the files and then load it into our Visual Studio and so on. So a few things over there to consider. The other things were, of course, the syntax readability and simplicity of code, of course. The programming constructs were easier to grasp in Python, I feel. And considering a number of primary schools are now using block-based code, the next step by default goes to Python, and teachers are leading extension students in that direction. They say, even if they don't know the language, they just say, yeah, go and learn some Python. And also, this could possibly mean that we could make time to actually teaching computer science principles rather than just focusing on the skills. And we also consider that this is more relevant to industry. For example, we talk about apps being made like Instagram made on Python, and your usual recommender systems on Netflix and Spotify are all using some sort of Python in the backend. Not forgetting the array of large number of libraries accessible to us, including Pygame that I'll talk about what we did with the year 10s. And also we had a student, a university student now, who's an ex-student of our college, keeps coming back and helping out with our senior classes. And he said the first time when he told his classmates that he learned Weeby, everyone was like clueless as to what Weeby actually was. So these were some of the reasons that we thought about before we started migrating towards our next, starting our journey.
Excellent. So one of the key considerations for how to roll this change out was to minimise the impact to the Year 12 students. We were unable to do a big bang approach to all year levels, so we decided by piloting with a few low impact subjects. At Year 10, as you can see from the visual, students can select Software Development Foundation as a first semester subject in Year 10. And then if they would like to complete the accelerated pathway, they complete a second semester extension subject. If their results are above a certain standard, they're supported to complete Software Development Units 3 and 4 in Year 11. It was the second semester extension subject that's highlighted up there, where we piloted the transition to Python, as generally students in this subject are high achieving and would be able to cope with the change to a new language. Pravin will focus on this shortly. However, the other subject identified was the Year 8 Enhancement STEM program. There's no formal digital technology subject at Year 8. However, we do have an invitation-only enhancement subject, which is offered after school 1 day a week. And students, the top 20 students in maths and science, are invited to join the program, with the focus being STEM-based concepts. Students work through various units, including robotics, VR and AR exploration through CoSpaces, and drones using drone blocks. This year, with the understanding that Python was the language of choice for the school going forward, we embarked on a bigger project where we piloted the use of Python with students using a Raspberry Pi Pico to create a self-scoring basketball kit, as you can see in the first two images on the slide. Students use the Thonny IDE with the MicroPython extension to code the ultrasonic sensor to detect a goal and an LED matrix to keep track of the score. Due to the complexity of the code, students were provided with the base code, which you can see an extract in the third image, and through the completion of tracing, annotation and testing, they were able to fill in the blanks to create a working program. We also found practical ways of teaching concepts like variables and data structures, which were required for the final code. We used a simple laser cut container model over there, as you can see in the last image, and students were able to more easily grasp abstract concepts and apply them to their code. Students completing the course cited the Python programming component to be the most challenging part of the entire project, however, also the most rewarding when they were able to get their code working. This feedback affirmed our current approach of using block coding in the lower year levels to build those skills before students progress to Python. However, there's definitely an opportunity to challenge our enhancement students, and the key takeaways from teaching Python this year at the Year 8 level was to incorporate more aspects of Python throughout the course to improve outcomes in the later years. So we're currently exploring the use of coding with Python in CoSpaces and adapting our Lego EV3 robots to use MicroPython. This will provide multiple exposures throughout the year to Python programming in different contexts, and this will allow students to progressively build and apply skills, thus preparing them for software development in later years.
So looking at our current Year 10 VB setup, it's basically 2 semesters. Each semester is about 20 weeks long. First semester runs the foundation course, which has basic concepts like data types, naming conventions, creating simple forms using the toolbox, so drag and drop items. Students spend a lot of time creating ASCII art using console.writeline. In doing so, they learned logic, loops and conditionals. They made some simple conversion calculators, and mainly button-focused apps, as well as some console apps. And the extension program is available in the second half of the year. So except for a few students who don't choose it, most of the students who do foundation continue to do extension. So in extension, the students would learn some advanced data types that they haven't used before, something like, I don't know, Boolean or whatever. But they'd make things like dates and applications, or creating an image gallery app, multiple forms, list boxes, and the big focus would be the game project or an adventure game project, which would last for many weeks. And the focus was on project management, where students need to manage their project using something like a Gantt chart of some sort. This is to prepare them for the project management that comes up in VC 3.4, which follows the problem-solving methodology that has the analysis, design, development, evaluation stages. So they're encouraged to use that, and it's marked. So there's a big focus on that. So, where are we? Sorry. So our school's in the middle of a transition phase between service providers. So currently, we're transitioning from Google to Microsoft, and most of our resources would be set up something like this. We'd have a site which has a number of pages, and each resource or weekly task would be as a page, and students would go access that page, and they would create their own Google site showing their work, recorded work on there, and they would share it with us. So it's just a matter of setting up these pages each year for the next set of students. So this is the new look Python course that we proposed, and we haven't run the foundation course yet. We are going to, actually next week, we're going to be starting it next week. We've got 2 weeks of transition, so starting next week and the next 6 months. So the focus would start with understanding algorithms, starting with simple problems in real life and putting them down as an algorithm or a pseudocode, how to solve that problem, focusing on creating some simple flowcharts and so on. So in that process, we'll be focusing on computer science principles such as computational thinking. We'd then get into variables, loops, and conditionals using something simple like idle, because setting up PyCharm can take some time with the IT because they have to deploy it to Software Center, and then, yeah, it's, as you know. In that process, students will learn about variables, loops, conditionals, and we aim to use W3 Schools as a major resource. In fact, I remember that Alison this morning talked about how important worked examples are in the learning, and I think W3 Schools is a fantastic resource because you've got worked examples and it says try it yourself, and so then you can click on there and then actually go and try it in the web editor, which is fantastic. In the extension program, which we have run in the last 6 months, so that was the transition, Students who had learned VB in the first semester were learning Python in the second semester, used PyCharm as the editor. They learned new data types which they hadn't learned in VB. They focused on project management because that is part of the learning, so they had to build a game. But this time they used Pygame, so we had to teach them about libraries, how to include a library, how to pull things out of a library, and also concepts of object-oriented paradigms, so I'll show an example of that. And we also have a exam which has a theory and a practical component. So the theory is an hour of question and answers written on paper, and the practical component is when they actually build something using software. So this year we had a pizza ordering system using a console-based system. So in doing so, moving from VB to Python, we compared the code for creating a list, and that is what it looked like. So we reminded students this is what you would have made using VB, and that's the same list you would make using Python. That's exactly the same. That example, of course, is taken from Microsoft's how to create a list. So we show them how much clutter is reduced when you use Python and object-oriented style programming. The importance of live coding and learning together with the class was very important for us to part of the teaching process, because you've got to remind students that you make mistakes and it's part of the learning process. So we basically type on the screen and the students look at it and they say, oh yeah, that's not going to work, or that'll work, some sort of prediction model, and then they try it out and it doesn't work, and how do you fix it? So we learn a lot from YouTubers, because there's quite a few YouTubers who do live coding sessions like Coding Train, David Malin on CS50, and Centex, who are really good live tutors. Another part of the extension course was to try and bring in industry to talk about the actual process and meet real coders. Like, at the end of the day, we're teachers. At least I don't have any industry experience. It's awesome to bring those people in and show them actual code being made. So we had Danger Thumbs, who are a small team of game developers out in Berwick, and they came out and showcased the game called Footy Bash, which is coming out on Steam pretty soon, or it's come out already. But basically, they focused on areas, things like reusing code and how to make code that lasts long, things like how do you manage a large project and allocating work to different team members, and then accepting user back and that software design lifecycle. So those are key things that they wouldn't have learned from us in terms of software development. So one of the opportunities we had for students is to not freak out when they see errors on the screen. So for example, in here, when you miss some syntax in VB, it throws up 4 errors just for one thing, because it detects everything below it as an error as well. So here you can see 4 errors for just taking out. Yeah, it was strange. So trying to show students that getting errors is part of the process. So we made a simple worksheet for that, where students would identify the code. So that's the code on the left that they have to type in. And they got to work out what the error is and write that in, and then fix the code up. And that becomes their cheat sheet that they can keep as part of their learning process. Another important thing was to direct the students to the actual Python documentation, so that they get familiarized with it, so they're not, it doesn't look strange to them when they go to that documentation page. So looking back at that feedback from the last 6 months that we've had, of course, it wasn't an official research. We didn't do the ethics, but it's just a back and forth Microsoft Forms kind of quiz, VB or Python, and why. Most of the general responses were like, it's more straightforward and fun, and we didn't realize that. Of course, the touchpads are quite greasy because kids' hands not clean. I didn't realize how hard it is to drag and drop items over, so that was a problem we never thought about. But also we got responses supporting VB, saying it was hard to detect, hard to find things like buttons that they were used to dragging and dropping earlier, and they didn't understand the concept. So there's definitely some amount of learning for us to do as to how to, create a button or look at web apps such as Anvil, which can drag and drop and do the same sort of thing. But there was mixed responses, but mostly in support of Python. So wrapping up, it's been a challenging yet rewarding experience for both staff and students. I feel that we have learned a lot in terms of how to set up a course and transitioning in the middle of the year, but also for the students who had to do that awful job of the transition and looking at different pieces of syntax and code and working out and get through that year, especially with the assignments and stuff. And hopefully, with our foundation course starting soon, we're looking at different opportunities here, possibly some sort of, like Anvil, where we can still get like that drag and drop opportunity. But it does look a little bit more complex with those decorators. If you've used Anvil, it throws up all these asterisk things, and you're like trying to work out what that actually is. Future scope, we've got a robotics team set up who are competing in the FRC. And the FRC is an international competition where they build a robot that's about 25 kilos. And the first 30 seconds of that challenge is to build something autonomous to complete certain tasks. And the students get a choice of Python, C++, or Java. And our students have chosen Python because they're starting to get comfortable using that language, and there'll be a bit of consistency. We've put in a request for a class set of Raspberry Pis for next year to do some headless computing so that students can code directly to a Pi. Things can light up, and without having the need of an overhead of a screen, just try to SSH into it somehow. But now that we've seen Damien and Julian's Kookaberry, we might be deviating towards that as a cheaper solution. And lastly, as the LMS coordinator, looking at opportunities to integrate some sort of self-learning modules. So I found one called Code.io, which basically marks and assigns assignments to your students, self-marks, and then sends the mark to your LMS of choice as well. It uses something called as some LTI, which basically connects between LMSs and systems. So that would be awesome to automate some of those jobs, which will get us to actually sit down with students and help them out if we can assign modules to do some flipped learning in coding. So where are we? We're always looking at ways to incorporate more practical hands-on coding. So in this case, with the help of our STEM technician, Peter Saks-Jarvi, we developed this simple setup, a traffic light setup. So underneath sits a Raspberry Pi 5. All of the LEDs are wired up, and there are little switches on the road. So slightly different to how a road works, because I think it's magnetic or whatever the sensors are on the road, or metal sensors. This one has got switches, but basically we put the thing out to the students, and they got to try and work out an algorithm to keep the traffic flowing. And they got to, and then there'll be a train line as well, and pedestrians as well. So it can get as complex as you want it, and students got to come up with an algorithm flowchart and then actually deploy the code. So currently, the problem we're facing with that is actually sending the code to the Raspberry Pi via SSH, because at one time you can have one connection, and we don't want to get students sending all sorts of codes directly to the Pi. So we're trying to work out a way in which it'll be it'll work seamlessly. And lastly, one of the other kits that we had looked at updating from our EV3 kits, because we had some issues with the MicroPython unit. So here we've found the McQueen pluses, which sort of use the microbit and the Python mode on it. We could be used to teach students how to code and set up a whole range of different challenges. one of the things that we've noticed is in the Year 7 course that we run with the microbits is that when you use the slide feature between the blocks and Python, the translation is not necessarily the same. So you think that you can show, oh yeah, students have a look at this and then have a look at Python and you'll get a grasp. It doesn't really work that way because the interpretation of that code is not straightforward. So sometimes students, or most times students would get confused. So what we suggested for those students who are really keen to get onto Python using the microbits to use the actual Python editor for microbits, which has got a very nice clean interface rather than doing the slide switch. And that is us. That's our journey for the last 6 months, and we'd love to take some questions. Oh, thank you.
Fantastic. We have questions. Hello.
Hello.
Sorry, I need to remind the room, not that I think we're going to have any trouble, please phrase your question as a question.
I just had one question.
Sure.
I did software development last year because I'm a Year 12 student this year at the moment, so I accelerated it. How did you guys do like your SAT or your school assessed task in Python? Because I use Swift at my school and we did like all of the UI, it's like drag and drop, and it made it quite easy. Did you guys have like any user interfaces on your SATs, or
No.
do you?
So this year
No.
we are still using Visual Basic because we didn't want to interrupt students this year who haven't been studying Python and then just drop them into it in Year 12. I don't think that's fair. So they were using Visual Basic this year. We're still exploring how we're going to do that for the SAT with the Year 12 teacher.
We might have a situation where there might be a few students doing VB because they prefer to do it, and some students who have done the Year 10 extension course to do, well, we're confident with Python, we're going to go with it. So there
Yeah.
could be a situation. So we haven't done it yet.
I have a question as well, and this is more of a technical curriculum-y type question. I'm really familiar with the Victorian curriculum and the Australian curriculum, and part of the 7 and 8 mandatory curriculum is that they learn a general purpose programming language at Year 7 and 8. You mentioned that you've got plans to do some implementation of that. Do you have plans of continuing that rollout over the next few years?
You want to take it?
I'll let you because you're Year 7.
Yeah, so the idea is to, well, currently our course has got a scripting language, so we've got HTML, CSS, a little bit of JavaScript, but it's more like using, what was it, Trinket or something like that. It's basically type up the code online on a web browser and you see the web page next to it. We'd love to get that actually on Notepad, so students starting with a blank screen, Notepad, 6 lines of code makes like a nice little page. But that doesn't answer your questions. That's not coding because that's scripting. So we've used microbits, and we think we want to continue with microbits at the Year 7 course to teach concepts of coding. But we definitely want to increase the focus on computational thinking and problem solving and using code as a solution rather than teaching them how to code.
Do we have any other questions? Take the microphone. We would, if anyone, please still think if you do have any more questions.
I can ask the question. You mentioned Anvil. I'm exploring that for next year. How much time have you spent there? Like, wouldn't that be a good replacement for year 11 and 12?
Yeah, it would be.
Yes, yeah.
I used it last year for applied computing at my previous school, and we made web apps using Anvil. They've got some fantastic setup tutorials, like how to create a backend server with the database and a front end, everything in one nice package. The challenges that we faced was the decorators. So when it open up, you double click on a button and drag and drop, it brings in all these decorators which students are not exposed to. So we had that challenge, so we try to teach them Python using idle and printing things to a screen, going over those basics before getting Anvil in. So rather than introducing them straight to Anvil, we said, learn Python first, learn how to print things, all your loops, conditionals, logic, all of those things on idle, or Tony, or whatever you want to use, or web editor, and then bringing in Anvil, just because of the complexity of the add-ons that it throws.
And the way that will work with the pathways, Year 10 foundation will probably just stay within the IDLE, and then we'll look at AMPHIL for the extension subject, and then Year 11 and 12 will follow on with that. So I think that's how we're thinking of it at the moment. Thank you. Thanks.
Wonderful. Would love to give them a big round of applause. Thank you so much to Prav and Carolyn.
Oh, thank you.